Welcome to Try a Maths Problem Today. I recommend you pause the video and try it yourself before continuing on and watching my solution.
We are asked to find the coordinates of the stationary point of this curve here. Now, whenever we hear stationary point, the first thing you should be thinking is dy dx. And in fact, dy dx being equal to 0 at a stationary point. We're also only interested in the domain x bigger than 0 and less than pi over 2. That'll only become important later on in the question. So how do we differentiate this? That's really what we're being asked. And we need to notice this is made up of two terms multiplying each other. So most likely we're going to use the product rule. So let's try that. The product rule tells us to differentiate the first term, and that's e to the power 2x. The derivative of that is e to the power 2x multiplied by the derivative of this power. So that's multiplied by 2. And then we leave the second term alone. This is back to being the product rule. Sine 2x. Then we add on, we leave this guy alone, e to the 2x, and we multiply by the derivative of a sine. The derivative of sine is cosine 2x, or cosine whatever's here, multiplied by the derivative of what's here. In this case, it is 2. Let's put it in here in a bracket. Okay, and we know all of this equals 0 because it's a stationary point. So let's try and expand things out of this. There's common terms in both of these terms. In all three, you could think 0 has everything in it. So 2e to the power of 2x goes into both of them. 2e to the power of 2x goes into this one sine 2x times, and it goes into this one cosine 2x times. So this gives us two answers really. This gives us this is equal to 0 or this is equal to 0. Let me deal with this guy first because there's a problem with that. This tells me 2e to the power of 2x equals 0, and e to the 2x is equal, divide both sides by 2 is equal to 0. There's a problem here. E to the power of something looks like this. It goes up something like this. It approaches 0 all the way down here. So if this equals 0, then that tells me that 2x approaches minus infinity, or x approaches minus infinity. That's okay, that's a perfectly okay answer, except we're only dealing with this world. So we're not interested in anything less than 0, let alone minus infinity. So we'll ignore that answer. That answer can't be right in this case. So what could be 0? It must be this guy here. So we'll go sine 2x plus cosine 2x equals 0. How do we solve this? There's only one unknown, x, so we can solve this. It's a fairly common equation to see, so it's good to remember the technique for solving something like this, because lots of students get stuck at this point. So how do we solve it? Let's move one over one of the sides. It doesn't really matter, although it's better to leave sine. Well, I guess sine will be on one side no matter what you do. Sine 2x is equal minus cosine 2x. Now the trick at this point is to notice that if you divide both sides by cosine 2x, this side will disappear and this side will combine into one term we know. So if we divide both of them by cosine 2x, this becomes tangent 2x. And this becomes, well, I said disappear, but it turns into a minus 1. This turns into tangent 2 of x is equal minus 1. If we go ahead and solve this, take the inverse tangent of both sides. On the left side it will destroy this tan, and on the right side that will equal to the inverse tangent of minus 1. You can go ahead and try and solve this. We're going to have a problem at this point. I'll continue on before going back a moment. We would get 2x is equal minus pi over 4. X then would equal minus pi over 8. It's a problem though, that's not the answer. That's not an answer that's acceptable to us because it's outside the domain we're looking for. And so what happened there? This happens in all trigonometric questions really. These things go on forever. So I'm going to draw this one here because this is the tangent. I don't want to have to deal with x yet. I'll deal with 2x for now. That looks like something like this at least. I'll go up like that, continue down there. Again here and again here, something like this. Hopefully you've seen a graphical representation of tan before. This will be around pi, well around exactly pi. This will be at 2 pi, And the answer we're looking for, tangent of something equals -1. Let's just say -1 is down here. -1 gives an answer here, here, and here. We get loads of answers. The calculator, though, at this point here is when we use the calculator. The calculator only gave us this answer. This line is not really correct. The truth up here should be infinite answers. So that's where we have to be careful solving any of these. So the real answer here is not only -π/4, it's this one here, this number here, this number here. So how do we get that? I like to think of it as this. The distance between 0 and -π/4 is π/4. So the same gap is here. This is also π/4 away from pi. So pi minus this is 3/4 pi. And the same up here. This one would be 7/4 pi, and so on. And this is, and again, also on the other side, there's millions of answers. So this isn't the only answer. Divide them all by 2. We get 3/8 pi. We get 7/8 pi. And this continues on forever. At this point, only at this point do I start, well, sometimes I think ahead, but at this point I look at the world I was dealing with. I was only dealing with x's bigger than 0 and less than π/2. And like I said, we couldn't accept this one as an answer. That one was gone. Also, we can't accept this one here. It's too big. It's over a half pi. It's gone. Everything on the right's gone. Everything on the left. We're only left with this as an answer here. But we didn't just want the x number. We want the whole coordinates. Let me clean the board, make a little bit of room, and we'll find out what y is. So we know x is equal to 3/8 pi. Y is written right up here, and y is equal to e to the power of 2 times 3/8 pi multiplied by sine of 2 multiplied by 3/8 pi. We can clean a lot of this up. This is equal to e to the power of 3/4 pi. Sine of 3/4 pi, put that into a calculator, and we get the square root of 2/2. I never really got why they write it this way though, or the calculator, or a lot of textbooks. I often remember square root of 2 goes into this square root of 2 times. So you'll also see it written as 1/√2 and then e to the 3/4 pi. Either way you want to write it is perfectly fine. But let's put them together into a coordinate form. So we just have 3/8 pi and 1/√2 e to the power of 3/4 pi. And that's the stationary point of this curve. Okay, thank you for watching and have a great day.